Welcome everyone. We are starting now. It's 16:30 already, and it's absolutely a pleasure to have all of you with us. Just as a check before we start again, give me a one if you are able to hear the video and audio and everything perfectly well. Just give me a one. Just type one in your chat box so I know that you're able to get the voice and video absolutely clearly. Perfect. Perfect. Thank you. Thank you for your feedback. It's wonderful to have such an audience. And we have with us moderator for this workshop, this webinar. That's Mr. Rashik. And if there is any problem in between, he'll be giving me a call. So if I take the call and talk to him, be sure that I'm doing it for conducting this webinar properly and without any hitches. So we had around 500 registrations for this webinar. As I can see, we have 221 attendees as of this moment. I hope others will join shortly, but without waiting for them, we will start. All right, so this is the presentation on subsurface utility engineering, and this is about detection and mapping of underground utilities. This has been brought to you by AF Academy. AF Academy provides training and knowledge sharing platform to decision and policymakers, working professionals, operating level personnel, and aspiring students willing to specialize in technical sectors through mediums of training and courses. We have conducted numerous these workshops offline, but this is the first webinar which we are conducted online because of corona. We had to really, because of COVID-19, a lot of workshops were cancelled this particular year, but knowledge dissemination and learning should never discontinue. So that's the spirit of doing this online webinar, and we are really thrilled with the kind of response we have got. These are a few glimpses of the workshops which have been conducted by AF Academy earlier. The topics which Academy has worked on included subsurface utility engineering, the one which we are going to discuss here, then rapid and cost-effective site. Okay. So I'm a geophysicist with 30 years of work experience. I started my career with the UP Electronics Corporation. I was primarily involved in well logging operations there. Then I went on to work for Atomic Energy, Department of Atomic Energy, that is Atomic Minerals Directorate. I am working with the various committees for development of codes and practices. I have conducted a number of training programs on use of geophysics for various companies in 9 countries. And as far as utility detection is concerned, I was the lead geophysicist for Delhi Metro Underground Corridor that was in 1996, which was the first commercial use of GPR in India. So in a way, pioneered the use of GPR in India at that time. And I'm experienced of working with most of the available GPR models in the world. Conducted first ever city level utility mapping project for city of Tirupur way back in 1999. Have various papers and publications, including the first paper, which was Advanced Technologies for Preparation of Utility Maps of Cities, which initiated many projects in India. Initiated the concept of SUE in India in 2001, what we are going to talk about today, subsurface utility engineering. And I'm the principal author of Indian Code and Standards for Subsurface Utility Engineering and expert panel member of various organizations. I am getting a few feedbacks about no audio, and one person is saying no video. So can I have a quick confirmation if most of us are getting this PPT on their screen? Just give me a 2. If you're getting the PPT on your screen, give me a 2, please. Okay, so lots of 2s. So we are getting the PPT on the screen. And if you are able to hear me properly, just give me a 5. Just give me a 5 if my voice is clear. All right. So I'm sorry, please check the connectivity at your end, those of you who are not able to get the audio or video properly, because as I can see here, most of us, 90%, in fact, are able to get it clearly. All right, so we go to the next. So this is a small poll which I would like to do with you, and I'll very quickly like you to give me this answer, and I'll just create this poll. It will come on your screen, and I will know exactly what you think about the problem which we are going to discuss today. Okay, the poll is: have you ever been involved in a construction project and encounter utilities that no one knew were there? Have you been in that kind of situation that you were working on any particular project? Let's say, it can be a small construction project, doing some piling somewhere for a flyover or putting a new cable or pipeline, and suddenly you discovered a utility which no one actually knew is there. Just do yes and no when I now the poll is open. You can do a yes or no. Interesting. So you have around 66% people that they have been in the situation where they have been involved in a construction project and encountered utilities that no one knew were there. So these utilities came with a surprise element for these many people. Perfect. So why it happens is that if you really go and look at your underground, this is how it looks like. It's actually a jungle of utilities down there. You have utilities going in practically every direction. These are actual images. This is the image of how the underground looks like in a city. This is right from our Okla in New Delhi, how the utilities look in underground. This is so what happens is that the footprint of new construction, repair, or remediation often conflict with existing infrastructure. The hidden or buried infrastructure is often detected in the construction phase because you generally do not have information on this infrastructure. So as you go in the construction phase, that's where this infrastructure is detected. But that time, the cost of conflict resolution and potential for catastrophic damages are highest. I think it's very simple to understand. You already have your man and machinery on the site. You have started your work, and then suddenly you come across a utility which you never knew was there. Now relocating this utility, etc., etc., obviously is going to take time. Until that time, your men and machinery is going to be idle. That's number one. And number two is that if you hit the utility by any chance, for example, there have been accidents in Mumbai, there have been accidents in Kanpur, where gas pipelines have been hit, and there have been major catastrophic damages because of that. Electrical cable being hit is a very, very normal thing. It keeps happening, and obviously, sometimes it results in fatalities also. All right. So the typical design phase is something like this. We are sitting on a chart paper here. One guy is saying, I think the gas line is here, but I'm not really sure. It might be in conflict with this proposed piling. The other guy says, I guess we will let the contractor worry about that. Now, this makes it extremely difficult to manage the risks that are created by existing underground utilities. Because the fact remains that the contractor works on the design given by the consultant. Consultant makes on the design mostly based on the background information provided by what we call client. And ultimately, no one takes the responsibility of what's happening there. So the problem is that first of all, there is no central repository for location of underground utilities. We do not have a single a department or a single number where we can just call up and or we can go there and say, okay, give me repository of all the underground utilities. No single agency monitoring the laying of new utilities. So even if, for example, you have a very updated database today, tomorrow it will change. because no one is updating this. Non-availability of ABDs, that is as-built drawings, we know it very well that as-built drawings generally are replica of as-designed drawings. Now that goes back to our contractual issues. I'm not going to discuss that here, but that's how it is. And then covering of manholes and inspection covers during laying of the roads. When we are putting a new road carpet, a new road layer, the existing manholes and inspection covers are buried under that. That actually has been a great business for many people when Delhi Metro project was going on, because whenever they had to trace a sewer line, they really had to work very hard for that because all the manholes were already covered by the road cover. So with all this limited information, practically no information, we are the smart decision makers. So it's practically taking a decision with your eyes closed with such limited information. So we need smart solutions. Why we need a smart solution is, one is we don't know where most utilities are. Existing records are often inaccurate or incomplete, and risks become extremely difficult to manage. And what are these risks? Project delays. If you encounter a utility which you didn't know was there and it is actually encountered during the time of your project execution, suddenly everything stops. Damage to utilities. It is living in any country, we often see that utility has been damaged, there has been flooding because a water pipe has been cut, there has been data disruption because a fiber optic cable has been cut, there's been power disruption because a power cable has been cut, and the list goes on. Safety of workers, as I said, if you really hit a live cable or you hit a gas pipeline, safety of public, redesign cost, change orders, bad publicity. So all these are the risks which we are talking about, and that's why we need smart solutions. Are we okay? Everyone is with me till now? Do we agree with all these observations? Give me a one so that I know we are on the same page. Let's have a one quickly. That's the difference between a webinar and a real live session. There we are able to see the faces. Here I can't see anyone, and I really don't know, like, okay, all right, so lots of ones. So, well, we are together. Great. Great. Thank you very much. Thank you so much. All right. So what is the solution? Let's look at the solution. So first, before we start of this solution, I'll just like to give you another poll because this is very important. This is a very important thing which we need to look at, and we'll just quickly do it. So this is your another poll, and this goes like this, right? I'm just typing very shortly. I'll explain you when I publish the poll, and then we will go for it. Okay. All right. Now, poll is there in your poll box. It is saying, in your opinion, which is the most suitable, appropriate method or procedure to create maps of underground utilities? First is GPR, second is EPL, third is trenching, and fourth is other. Just quickly write whichever is the answer you think is the right answer. GPR, of course, stands for ground penetrating radar. EPL is electronic pipe locator, also called induction locator. Trenching is obviously opening the ground and seeing what is there. And other is if you think that these three actually are not completely adequate, but there has to be something else, then go for other. All right, very interesting. So we have around, still it is coming, but okay, broadly I've got the picture. Around 80% are saying that GPR is the tool which is most suitable or appropriate method or procedure to create maps of underground utilities. 5% are saying, or 6% are saying EPL, 7% are saying trenching. So EPL and trenching are kind of tied together, and 6% are saying there has to be something else. So 78% are with GPR. Thank you very much for this. Okay. All right. So we'll go to our next slide. I'll come to the answer of this later. Okay. So what is the answer? So the answer is what we are discussing today. and that is SUE, Subsurface Utility Engineering. It is using new technologies for solutions, that is surface geophysics, surveying techniques, CAD and GIS, minimally intrusive excavation, convergence and systematic use of data. This complete together makes what we call SUE. Now, believe me, I started GPR in India in private sector in 1996, as I introduced in my previous slide. Now, after that, of course, I went on promoting the technology because that time this was the technology to detect underground utilities, and we did it for Delhi Metro project. They were struggling for almost 3 years, putting all the data together of underground utilities, and somehow they were not able to achieve it. That was the time when I had just come back from Montreal. I had seen the use of GPR, and I happened to meet just a very senior level person from Wright's Urban Transport Division. That was a organization that time which was involved in this. Delhi Metro was not constituted by that time, and he said, "Is there any solution for detecting underground utilities?" And I said, why not? Let's do GPR. That's how GPR started. I kept promoting it. In 2001, in fact, Supreme Court came up with an order after the accident in Mumbai that all the trenchless projects GPR must be conducted before it. And then, after some time, I was the one who started educating clients that if you are depending only and only on GPR for mapping of utilities, the chances of success are just 40%. And in 60% cases you might meet with disappointment. Now that might come as a shocker to the people who said 70% of you almost that GPR is the best solution for that. All right, so we will go with this, that there are so many limitations of different techniques, and that's why I'm talking about this entire concept of SUE, the procedure. It's not a single technique, it's a procedure. So let's go ahead. So what is subsurface utility engineering? It is a proven process that incorporates new and existing technologies to accurately map underground utilities during the development of future construction projects. It encompasses several separate activities, including designating, locating, surveying, and mapping, all of which are performed under a professional program of data management. So it is basically a process. It's not a single tool, it's a process. And you will understand why it's so important to talk about this process and understand this process if we have to actually make our excavation safer. The essence of subsurface utility engineering is simple. Before an engineer designs a project involving excavation, the engineer should know what structures and conditions are beneath the earth and where they are in 3 dimensions. Such structures are usually utilities, but may include underground storage tanks, septic fields, and other things. Subsurface utility engineering involves the collection of underground utility data and the use of that data by the right parties at the right time. Its major components is designating, locating, surveying, and mapping, and data management can be defined in terms of quality levels of information. You will understand about this quality level part as we go further in this. This is actually the most important part of the entire process of SUE, which you need to understand. Quality levels may be thought of a degree of risk or how much information is really needed before planning, designing, and constructing a project. Now, when we talk about quality level, I always love to start with this real world example. We meet, okay, I just got a message, no voice. Can again everyone give me a confirmation on everything all right? That is audio, PPT, everything is all right. Just give me a one if everything is all right for most of us. All right, lots of ones. So, Veeraji, uh, please, you have to maybe reconnect at your end because here I'm getting all the ones from more than 300 people that they are able to really listen to it fine. Thank you. All right. So I would love to start with this real life example. We meet hundreds and thousands of people in their life, in our lifetime. Do we have anything written on their forehead that whether we can trust them, they are reliable, or they're 100% reliable, or 75% reliable, or 50% reliable, or totally unreliable? Unfortunately, not. And that's why we have to really go through a lot of struggle in life. We get cheated, uh, we are betrayed, we have all kind of problems because it doesn't come with a label that this person is this much reliable. Now same is the case, unfortunately, with the maps which we work with. Now look at this map. This is an old ammonia print. People of my age understand this map very well. This is what we used to have. These are ammonia print. They were printed in, they were kind of made on a transparency and then printed in ammonia print. And this is what we used to have. It's slight bluish color. And this is what we used to work with. Now, this is a map of some city. It is showing certain lines here in different sketch pen, blue and gray and red and whatever. Now, if you look at this particular map, it becomes very clear that it is just a schematic map of where the utilities are there on the roads. That is, on which road a utility is there, on which road utility is not there, right? Because sometimes the entire road is having a width of 2 millimeters in the map, and then you make a line with a 1 millimeter on that. So that sketch pen takes almost all the width of the road to show a particular utility. So not a problem, right? So we know what it is. Now the problem happens when this map now in the modern time goes to a CAD operator. A CAD operator digitizes this map. Now he digitizes the road. He knows the road width is 20 meters. So he makes a line here, one edge, second edge, 20 meters is the road width now. Okay. Now he has to put this line somewhere, this water line somewhere. Now whether he puts on the left or the right or the center is completely left at his imagination. So he just puts the line there, period. So information has been created during the process of digitization, the information which did not exist. Now when this digital map is delivered to you of, let's say, one particular colony, you take the map, you're working on one particular road or street, you just zoom that area, and now you actually measure from the road edge how far is the water line. You can do it actually sitting on your computer in a CAD program. So what happens is now you know from the road edge, this line is 1.23 meters away. The information has been created, which was never there. The point is, please answer me this question. Do we have information on reliability level of maps? Do we have information on data used for map preparation? Once we get a map, does it clearly write that this is reliable 100%, 75%, 50%, 25%? Yes or no? Just give me a yes or no. Kuldeep Sharma ji, you have to reconnect if you are having a voice problem because everyone else is able to hear me loud and clear. No. All right. So that's the problem. The maps, when come to us, do not have any information about the reliability level or the process of information gathering for that particular map. Now that's a big problem. So the information has been created during digitization, and we make our assessment just based on how beautiful the map is looking. If it is a blueprint, we know it's just a schematic diagram. If it is good CAD map, wow, this must be accurate. So the accuracy is being linked with how the information is being presented, not with how the information is being gathered. So coming to subsurface utility engineering, the basics of it. So SUE establishes credible nomenclature system to fix attributes to utility information to denote quality of utility information. That is, once you go through the process of SUE, you are basically looking at what is the reliability level of the map. So you are able to look at the map and say that this information is 100% accurate, this is 75% accurate, this is 50% accurate, and this might not be accurate. That's how credible nomenclature system is fixed to each utility. Now the standards are there, of course, for this, which deals with how the information can be obtained, what technologies are available to obtain the information, how that information can be conveyed to the information users. Intent is to reduce risk by improving the reliability of information on existing subsurface utilities in a defined manner. So as I said, it's a process. Now, those of you who are not getting the voice intermittently, there is some problem. I'm sure it is the connectivity issue because not everyone is having the same level of connectivity. I am this time having a good connectivity, a good signal, and most of the people are getting it loud and clear. So I will just reassure you that please be with me. All this recording will be shared with you so that you can, if you have missed it, you can look at that part again. So there are certain definitions which are important to understand because otherwise there can be a confusion in what do we call what. So when we say designating, it is using the geophysics for presence and approximate position of a utility. Locating in terms of SUE is exposing and recording precise vertical and horizontal position. Minimally intrusive excavation can be vacuum excavation, water jet, careful hand tool uses. SUE engineer is a person who by education and experience is qualified to practice subsurface utility engineering. Utility depiction is a visual image of existing utility information using a computer-aided design and drafting system or on project plan sheets. And quality level, this is the most important thing, is the opinion of quality and reliability of the utility information. Please remember that this is quality level is one of the most important aspects of SUE. So we have basically 4 different quality levels in subsurface utility engineering. One is called the quality level D. Quality level D is information gathered solely from existing utility records. This is what was being tried in case of Delhi Metro, as I gave the example in 96-97. They contacted all the utility owners across the city, collected okay, I would request you to please keep your questions for the end. I will have at least half an hour for the question and answer. So we'll, because at this time, even if you put a question there, I'll not be able to answer that. Please keep the questions for the later. So now you collect all the existing information from existing utility records, and that is what we call quality level D. The next quality level is quality level C. So now in this quality level, you actually take your surveying equipment, you go in the field, you pick up the above ground utility facilities like water walls and manholes, and pick all the features which are linked to a utility and put them there. And that is then adjust the information which you already received from background, and that's what quality level C. Quality level B uses surface geophysical techniques to determine the existence and horizontal position of underground utilities. That's what we call geophysical surveys. So for example, GPR, induction locator, acoustic locator, gas pipeline locator, all these tools, in fact, there are total 19 tools which can be used for detection of underground utilities in different conditions. Okay. But these are the tools which are used for these 4 tools are mostly used for quality level B information. So once I'm talking of this, now you might have got some idea that GPR or EPL or whatever we talked about right in the beginning is nothing but just one of the many tools in one of the processes of SUE. That is quality level B. That's the quality level for which they come in picture. And then quality level A. Quality level B also is not a guarantee in 3D. So quality level A employs non-destructive digging equipment at critical points to determine the precise horizontal and vertical position, as well as size and type of underground utility. There are standards for this. Okay, so just time to have one quick check. Are we together? Is the audio and video all right? Are we following the presentation in the right speed? Just give me a quick one if everyone is thumbs up on this. Great. So lots and lots of one. So we are having not any issue. So those of you who are having any kind of connectivity issue, you can please reconnect. Okay, you'll have a reconnect button. Please reconnect. And otherwise, of course, we will try to work with the recording, but best obviously is to listen it live. All right. So there is ASC standard, which is most popular in the world, and there is PAS. This is a British standard. This is the American standard. And then, of course, the unique nature of utility and record keeping in different countries necessitate various changes in the SUV approach. So, in fact, every country should come with their own standard. So, going by this, in 2018, we in India have come up with code of practice for subsurface utility engineering suiting Indian conditions. And I am also part of a small group which is doing the similar thing in Bahrain. I've given certain inputs in developing the code of practice for SUE there also. But this is something where I was the principal author, and this is out in 2018. All right. So now just looking at these quality levels briefly. So quality level D is the most basic and the least desirable level of data. Okay, this is the most basic. It comes solely from available utility owners' information. That is, you write to people, get information from them, and put that entire information together to make what we call a utility composite. It has application for planning purposes, such as selecting routes and estimating utility relocation cost. None of the quality level is useless in terms of SUE. Please remember that. And that's why this process is so important. Once you go to things like GPR and all that, like which I'll be discussing in this webinar later, you will understand that GPR, for example, doesn't give you the material of the pipe, it doesn't give you diameter of the pipe, etc., etc. Now there, if you have quality level D information from the department, you know in the year 1996, a pipe of diameter 36 inch was installed in this location, somewhere on this road. Doesn't matter where you will find out from your other techniques, but 36 inch, this critical information is coming from quality level D. Okay. What to expect in different places? This information is coming from quality level D. So it has application for planning purposes such as selecting routes and estimating relocation cost. Then even though quality level D information may provide an overall feel of the congestion of utilities, it is highly limited in terms of comprehensiveness and accuracy for design purpose. So it's good for the initial planning. When you're going to a city, you want to understand what kind of tools I need to use to actually detect, etc., etc. You need this information. Wonderful information to have. So this is usually adequate for route selection, but make no mistake, this level of data is not adequate for design purpose. So you cannot go in design purpose, but yes, your preliminary planning, you can work with this data. So this is record research. Recollections. It's a very important point of this quality level. You know, there's a shopkeeper, let's say, who is having his shop near a road for last 40 years. He has been there in that shop. He's joined that shop when he was a kid. Today he is grown up and he is still sitting there. He has seen practically all the excavation which has happened there. When a water pipeline was put, when a fiber optic cable was put, he knows that. He is a great source to tell you what kind of utilities you might find in a particular area. This is what we call recollection. There was absolutely no way of putting it at any drawing previously. But quality level D of SUE allows you to put these kind of recollection. Talking to the fitters, talking to the mechanics, the people who repair the pipelines, you can put it there. And of course, the as-built drawings, whatever as-built drawings are available. Now, these are a few examples of quality level D. So this is map showing only dia of sewer lines. So this is you can see different sewer lines, the diameters. Now it's a wonderful information because once you detect this pipe by, let's say by GPR, you will only know the depth to the top of the pipe. What about the bottom? So you have the diameter information here. So you'll know the top and the bottom. So that's why this information is very, very important. And the map showing only presence of pipeline. So it just shows that on these routes, the pipeline is there. So once you are surveying on these routes, you know that there is a pipeline there. Now this is again Faridabad showing different kind of pipelines with the OST. So this is what we call quality level D information taken from the background information. So of course, there are a lot of source of errors in this. First of all, data not referenced to change topographic features. For example, department is having a data which is showing a pipe on the side of the road. Now came the Commonwealth Games of 2010 80% roads of Delhi was widened, and suddenly this pipe is no more on the side where it has gone in the center. So it is not reference to the changed topo features. Now, inaccuracy also creeps in when the utility levels are not referenced to mean sea level. For example, you are showing a pipe at a depth of 1 meter. You're just showing depth from the top, and then comes one road layer of 20 centimeter. It goes to 1.2. Another road layer after a few years, it goes to 1.4. So like this, the depth will keep changing because you're adding road layers on the top of it. Now, this is not being documented. So this is an inaccuracy. And again, the last point is as designed reproduce as built. Most of the people know that as designed drawings are generally reproduced as built, because if as built is actually produced, contractors might have serious issues getting their payments. So this is a problem. Next quality level is quality level C. So historically, quality level C was probably the most commonly used level of information for design purpose. So this is what was most commonly used at one time. It involves supplementary quality level D information with an above ground survey of visible utility features such as manholes or wall boxes. Utility records and topside survey data are just not enough to provide an accurate picture of where subsurface utilities are located. Professional studies have shown a 30% error or omission rate with this approach. But till recently, this was the approach. You make a utility composite, then you just go and pick up the features of utilities and correct that composite, and that becomes your utility map. But 30% errors of omission. So it should not be used for design purpose. Okay. So it involves mapping of surface utility features like, as I said, junction boxes, manholes, it can be water walls, and the equipment usually use a total station and DGPS for this. Then comes the quality level B. Now, quality level B is the first level where subsurface utility data departs from traditional practices. So mostly quality level D and C is where we stopped in terms of earlier way of doing things. But quality level B is the first level where subsurface utility data departs from traditional practices. It involves supplementary quality level D information with designating, surveying, and mapping using surface geophysical technologies to find out the exact existence of underground utilities in plan view. Now, use of this information allows decisions to be made during the preliminary design phase of a project in order to avoid conflict with existing utilities. Slight adjustment in design can produce substantial cost savings and increase safety by eliminating utility relocation and moving excavation work away from existing utilities. So this is a very, very important quality level. And I'll be actually showing you a few videos now. And most of you just give me a quick feedback on the quality of voice and video, and everything is going fine with all of us. Just give me a 1. A quick 1 if everything is going fine with all of us here. Perfect. Great. So I'll just quickly play a few very interesting videos for you, because sometime a small video of 2 or 3 minutes can give you more information than if I keep talking for 15 minutes. So I have made this small collection of videos. So first technology which we generally talk about is GPR. So I'll show you 2 quick videos on GPR, and here you go. All right.
But just what is GPR? We asked Bernd Johansson at Malo Geoscience to briefly describe it to us.
First, radar is a short name for radio detection and ranging. Ground-penetrating radar is a technique which employs high-frequency pulsed radio waves in order to acquire subsurface information. By using this technique, we are able to find hidden metallic and non-metallic structures. A GPR system consists of an antenna, a control unit, and a display storage device. The system works like this. Electromagnetic waves radiate from the transmitting antenna. Buried objects or boundaries cause part of the wave to bounce back to the receiver where they are digitized. Along the server line, the transmitter continuously emits electromagnetic impulses which propagates through the media and reflects back to the receiver. The control unit gathers the signals from the receiver and transfers them to the storage and display. The GPR technique has some limitations though. For example, conductive soils may cause the radar waves to attenuate too fast. Basic rule for the use of different antennas is antennas with low frequency detect large objects at large depths. High frequency antennas detect small objects at small depths. We complement the GPR technology with other appropriate technologies, depending on the specific problem to solve. One such example is the EM technology. A cable carrying an alternating current produces a static electromagnetic field. The field lines can be thought of as concentric circles around the cable. A sensor, which is moved over the cable, can detect variations in this field and thereby locate the cable. This is referred to as an EM technique. In the CX product, designed for concrete investigations, we combine GPR with this EM technique.
All right. So I hope you enjoyed this video. Are you able to hear me? Fine. Did you enjoy the video? Great. So I'll just quickly play another very informative video on the technique of GPR, and these are very small videos, generally 2 minutes each. So I'll give you the YouTube links also. Idea is to very quickly go through these technologies because we are not going to spend a lot of time on these technologies in this webinar.
Welcome to the fundamentals and theory of ground-penetrating radar by Geophysical Survey Systems. We will introduce you to the basic concepts of GPR, how it works, and how to interpret the data as it is displayed on your screen. GPR stands for ground-penetrating radar. It's an electromagnetic energy signal that penetrates through the subsurface. GPR systems are typically comprised of 3 elements: the control unit, the antenna, and the survey encoder. Depending upon your application, your GPR system may differ from the one illustrated here. For example, the Structure Scan Mini contains all 3 components in one dedicated system. The antenna has a transmitter and a receiver. When the signals are returned to the antenna, we record a two-way travel time and the amplitude of the signal. The amplitude is simply the strength of the signal coming back. Antennas come in various frequencies, depending upon your application. High frequencies are for shallow depth and small targets, ideal for concrete applications. Low frequencies are for typically deeper depth and larger targets, such as utility, geological, and archaeological applications. Survey areas with high conductivity can limit the depth and effectiveness of ground-penetrating radar. An example of this would be clay soils, or uncured or green concrete. Here is an example of objects or targets underground and how the data will be displayed in real time. As you collect the data, note the hyperbolas, or upside-down U-shape, when targets are crossed at 90 degrees. When you back the antenna up, a cursor will appear on your screen. By bisecting the hyperbola with the cursor, this will mark the horizontal location of that target. Radar travels at different speeds through different mediums. A value is assigned to these mediums to represent different velocities of radar. This value is called dielectric. Dielectric is important so the depth of targets or layers can be accurately estimated. Air has a dielectric of 1, which means radar travels fastest through air. Water has a dielectric of 81, which means radar travels slowest in water. Every medium in the world falls somewhere in between. Lastly, remember that GPR is electromagnetic energy. Other sources of electromagnetic energy, such as cell phone towers and two-way radios, may interfere. These will not cause any damage, but may make it more difficult to see deeply into concrete or soil. In addition, unlike X-ray or other technologies, ground-penetrating radar is not harmful and has no site restrictions associated with use. This brings us to the conclusion of the theory and fundamentals of.
All right. So this was just to give a very, very quick overview of the technology of GPR, which basically is working on the principle of electromagnetic reflection. You're sending EM waves inside the ground, they are interacting with whatever is buried inside, and wherever there is a change in dielectric constant, a reflection is taking place from there. Now, it's a great technology. It can detect metallic and non-metallic and practically all kind of utilities. But the problem is that the success of this technique depends largely on the soil condition. For example, in certain soils, the dry soils which are having less conductivity, this is a wonderful technique. But if you go to conductive soils, you might not have any penetration altogether. So it is not something which can be applied with the same success rate everywhere. So it's a great tool in the toolkit of utility detection, but not something which can be used everywhere, and the only tool which can be used to detect underground utilities. So remember this. This is one of the important tools in the entire process of SUE. Now I'll show you the next important technique, which is induction locator. So I'll just show you the induction locator.
The basic principles of pipe and cable locating. Understanding the principles of pipe and cable locating will prepare you to effectively use Schonstedt locators and enhance your ability to determine target location, target depth, and the tracing distance. There are two methods of pipe and cable locating, both of which require the pipe or cable to be able to conduct electricity. In other words, they must be metallic. The first method is known as active locating, because a transmitter is used to impose the circulation of an electric current on the pipe or cable, and a receiver is used to detect the field created by the current. The second method is known as passive locating, because the receiver detects a field created by the current that's already circulating on the cable. No transmitter is required. Active locating requires you to create an electrical circuit through which current can flow. This can be accomplished with three different types of connections, known as active modes. The three active modes of connecting are direct, also known as conductive, inductive clamp, and inductive. The direct mode produces the largest amount of current and increases locating success. The inductive clamp mode produces less current, but it's a good choice when lack of access to the pipe or cable prevents you from using the direct mode. The inductive mode is often referred to as the drop-the-box method, because the transmitter's box is placed on the ground near the pipe or cable to induce the current. It produces far less current than direct or inductive clamp and should only be used when the other modes are not practical. With the direct method, you must make a direct connection to the pipe or cable being located. This concentrates the signal on the targeted line. First, take the clip attached to the red cable and apply it directly to the pipe or cable you're trying to locate. Make sure there is a good metal-to-metal contact. For best results, you may need to scrape or clean the surface at the point of contact. Next, position a ground stake as close to 90 degrees as possible to the anticipated line location path. Press the stake deep into the ground to increase surface contact with the soil. Once the ground stake is in position, apply the clip attached to the black cable to the ground stake to complete the circuit. It's important to complete the circuit by properly implementing a ground. In general, the better the ground, the better the signal. A current will now travel along the pipe or cable. As the signal travels, it gradually leaks into the ground and diminishes the farther it gets from the transmitter. one of the keys to getting a good signal is applying the proper frequency. If conditions are good conductor, connections, and soil conditions, the current will travel farther at the lowest frequency, with less leakage to adjacent structures. An increase in frequency will cause the signal to leak sooner and cover less distance. As a rule, always start with the lowest frequency possible and increase as needed. And remember, at higher frequencies, the current will leak to the ground quicker, which may impact your ability to accurately locate. By contrast, poor conditions, poor conductor, corrosion, non-conductive joints, etc., necessitate the use of higher frequencies to overcome potential obstacles. The inductive clamp method of connection requires you to apply a clamp around the pipe or cable. In some cases, the pipe or cable can be found next to buildings or on utility poles. Sometimes you'll need to dig to expose the line and be able to apply the clamp. It must close fully around the conductor. At least one end, but preferably both ends, the near and far of the pipe or cable, must be well grounded. Without a ground, the current will be extremely low, which will make locating nearly impossible. If only one end can be grounded, it should be the far end. Otherwise, most of the current will quickly flow from the clamp to the near grounded end. For the inductive method, an antenna that is either built into the transmitter or attached to it as an accessory generates a signal that induces a current on the target pipe or cable. Place the transmitter or the antenna attached to the transmitter on the ground, directly over the pipe or cable. The arrow on the label should be parallel to the anticipated traceline direction. Also, you must walk 15 to 20 feet away from the antenna before attempting to locate with the receiver. Otherwise, you will be picking up the signal directly from the antenna instead of through the target pipe or cable. If the transmitter isn't in the proper place, the signal is likely to be very weak. In addition, other nearby pipes or cables can complicate the locating process because the signal will be induced in them as well. Passive locating is the act of finding cables that already have a circulating current, such as buried power lines. The cable must be energized with a network distribution electrical current at a frequency of 60 or 50 Hz, depending on the part of the world in which you live. The passive method will not work if the power is off. Likewise, the intensity of the current circulating depends very much on the load. For example, running your house air conditioner versus charging your cell phone. One requires a lot more current than the other. Therefore, passive locating must be used with caution, and only when other methods are not possible. Schonstedt Instrument Company, making locating easier since 1953.
All right. So I just wanted to show you these videos, basically for you to understand that what all different methods are there. So for example, we talked about ground penetrating radar. It's a wonderful method. It has its own limitations in terms of the soil conditions. It also has a limitation in terms of the size of the utility. For example, for every 1 inch of diameter, the depth of burial should not be more than 1 feet. So if you want to detect a 3-inch utility, you can detect it good up to 3 feet. But if it goes beyond that, you might not be able to detect it. That is the depth diameter ratio. So there are a number of things regarding this. Of course, the purpose of this webinar is not to conduct training on GPR, which generally I conduct 3 to 5 days training on the topic of GPR itself. The second one, of course, we talked about induction locator. Again, very important method, having its own limitation in terms of congestion of the utilities, in terms of breakage in the utilities, the health of the utilities, etc. I am getting a lot of comments regarding the videos. They're getting paused and all that. So I'll just skip the other videos. I'll send you this link. This is another very commonly used method, which is acoustic locator. So what happens is sometimes you are able to locate the water mains very successfully, but the house connections, they are generally very small connections. So they can be 1/4 inch connection. They can be at a depth of 1.5 meters or 1.2 meters. They will not get detected by GPR. They are non-metallic. They can be of HDPE or they can be of PVC, so they will not be detected by your EPL, induction locator. So this is the tool for that. That's called acoustic locator. Then there are gas pipeline locator. They're separate tool only to detect the gas pipeline. As I said, there are some 19 different kind of geophysical methods which can be used for different applications. I got some question in my comment box, although I've requested that please put the questions towards the end of the webinar, which we'll take questions at that time. But since I'm on this topic, for example, if you want to detect a cross-country pipeline, you don't need to, and the area is forested, etc., etc. There's so many methods for that. You can use a magnetometer, you can use a EM. These four methods are one which are most applicable in the urban environment where there's a lot of noise in terms of electrical lines, cars, fences, and all that. But cross-country, there are so many other things which can be done. Okay, then come the quality level A. So this is the highest level of accuracy which is currently available. It involves adding locating to the quality level B information. For example, what quality level B will not give? It will give you the depth of the pipeline approximate. 5 to 7% error will always be there. It will not give you diameter. Anyone who comes to you and says that GPR gives diameter, don't trust him. GPR doesn't give diameter. Even in the project which I did 20 years back, I had given diameters of the utilities, but that's classification of diameter. That is from quality level D. You know that in this area there are three different sizes of pipe: 12 inches, 36 inches, 72 inches. Okay, you can classify them broadly using GPR. But to calculate diameter using GPR, well, it is possible in laboratory. The people who have done research on that, but in real field condition, no. So it's not possible. Condition, not possible. The pipeline material, not possible. So if you really want to go to the 100% guarantee in 3D, you have to expose the buried utilities. So locating is exposing of buried utilities to determine their precise horizontal and vertical position in plan and profile view. Now, what's the big difference between locating here and trenching? Generally, people talk about trenching is blind trenching. You just open up a road. It's not the case in quality level A here. Here you already have designated a particular utility and then just opening up a small hole of maybe 20 centimeters, 20 centimeters, doing a vacuum excavation and actually doing it. So the use of non-destructive vacuum excavation equipment and other technologies eliminate damage to underground utilities. The small test hole involves reduced impact on traffic. It's just 20 centimeter by 20 centimeter. And by knowing exactly where your utility is positioned in 3 dimensions, the designer can also make small adjustments to the final design elevations, horizontal locations, or structures types to further avoid relocating utilities or digging near them. The engineer also gets critical data about utility conditions, size, material types, soil conditions, and other important information. This is what is added by quality level A. So remember, if someone says that I want to get a GPR survey done here, and I want all the information on underground utilities 100%. First of all, if you're a client attending this webinar, please do not make such demands. If you are people who are service providers, please do not cater to such demands. It's simply not possible. You have to go through a process of SUE, and then at different level, you will know what exactly is deliverable. So this is what the quality level A looks like. This is a vacuum excavator truck. This is vacuum excavation. I had a small video on this, but I'll skip it. The quality level A data can also be collected through available openings like manholes, chambers, etc. to determine attributes of various utilities. You don't need to really dig every time. So for example, this is a covered utility. This supported stuff for utility checking. If we open this and then collect the data on a power cable, on freshwater pipeline, so we know what is the diameter of the pipeline, we know what is the diameter of the cable, the material of the pipeline, we have got the quality level A information without any digging and trenching. In fact, in busy cities like Mumbai and Delhi, this is how we have been collecting quality level A information for a long time. This is absolutely fine. Okay, this is a video. Link will be sent to you by the administrator of this conference. Okay. All right. Now, once we have all this information, we go to the next step of making subsurface utility maps. They should be made, of course, in adherence with the guidelines of the standard which is being followed. The most important thing of a map which is made by subsurface utility engineering is that all the utilities to be attributed a quality level. Period. That is the requirement. If a map is presented to you where a quality level has not been assigned to a particular utility, that is not acceptable as a SUV map. So what does it mean is that there will be a utility on the map which will say it is QLD. You will immediately know it is based only on the background information, it is least reliable. Then there will be a utility which will say quality level C. It has been matched with the surface features. Obviously, it will not have the information on the depth because it has been just done using the surface features. Okay. Quality level B. Now you will know that this information is fairly accurate because it has been done using geophysical tools. It has been detected right there on the ground. Okay. And then if some point they say quality level A, it becomes a guarantee in 3D. So that is how every utility should be marked with a quality level. The map which is presented to you is not saying that I am 100% accurate. There is nothing called 100% accurate. But the map is telling you how accurate I am in different utilities which I am showing you. So you can exactly decide how you are going to use that map. Okay. Of course, depending on the project, they can be scaled in different A3 size or whatever size is comfortable. They should be in a standard coordinate system rather than a local coordinate system so that they can be merged with data of the nearby areas. You can also put them on Google Map if it is in the right quality system. Depth of utilities should be clearly marked along with the utilities. Diameter, if it has come from quality level A, should be marked. If it has come from quality level D, it should be clearly marked that diameter has come from quality level D. Ideally, utility levels should be provided related to MSL, eliminating variations and errors when a new road layer is added. If we keep giving depth, it's a problem. Tomorrow they will add another layer and the depth will change. Another layer and the depth will change. So try to have MSL. In that case, you will not have that issue. These are the examples. So this is a legend example. This is from ASC. So for example, here you can see they have given different type of legend for different type of lines. And in notes, quality level A data point indicate by symbol. They have given a symbol. All quality level A elevations are for the top of the utility unless otherwise noted. All utilities depicted at quality level B unless indicated by dotted line code. So like this, you have to have a quality level associated with each single utility in your map. That's the basic requirement of SUV map. You can put it right along the utility like QLC, or you can give, for example, notes that all sanitary sewers are quality level C, gas, etc., is quality level D. That is, no surface features not detected by geophysics, only from the existing record. There is no quality level A data available in the area. Perfectly fine. So now you know the reliability level of different utilities in this map. This is another map you can see from some work. I think Pretty Woman Master Plan Road SK. Okay, this looks like Mumbai. So this is, for example, these are coordinates, UTM coordinates for both the corners. Different lines have been given, OFC, water, etc. Quality level has been given. Quality level B, depth is 0.7 meter. Cable, quality level B, depth is 1.4 meters. Quality level B and D. Why? Because depth is given there, but dia also is given 0.2 meter. Now this dia information has come from background information, quality level D information. Because as I told you, neither induction locator nor GPR gives you dia. So this information has come from background information. So this is how a SUE map looks like. So now, once you receive a map, it is written in the forehead, 100% reliable, 75% reliable, 50% reliable, or not reliable. Okay. Now, SUE doesn't follow any set pattern. It's not something that you have to go for all the quality levels and all the project. No, it is tailored to individual projects. So basically, first when a project comes up, it is systematically identifying the quality of utility information needed to design a project and acquiring and managing that level of information. That's the process of SUE. So for example, project planning, quality level D sometimes is good enough. Preliminary design, you have to go up to quality level B. Final design, you have to go up to quality level A with some test holes or opening the chambers, and then you go for construction. So please do not take away the message that for every project you have to go up to quality level A. That's not correct. It depends on what stage of the project you are and what information you need. All right. And SUE is a proven solution. This is not something which started in India. Now, whenever we talk about utilities and all that, we always say in India our systems are like this, our utilities are hazard, like haphazard, etc., etc. Look at US, look at Australia. They have all these. No, the entire concept of SUE started in the highway industry of United States, because when they were starting with their work, they realized that underground utility information available was not adequate to get into construction. Ultimately, they introduced the concept of SUE, and the average is that the return on investment is $14 for every dollar is spent on SUE. $14 for every dollar spent. And most of them say that it's beyond just the dollar saved. It's also about keeping our projects on schedule, finishing our projects on time. There is, of course, a need for standardization of SUE, because how you engage a SUE provider is as important as whether you engage one at all, because an inaccurate subsurface utility data is as dangerous, or at times more dangerous, than no data. So SUE service provider should be responsible for the accuracy and reliability of the data. So accountability is the key. Written quality assurance procedures. It's an interpretive science, so experience is very important. Equipment inventory is very important. The service provider should have all the equipment available so that he is not depending only on GPR or only on EPL. There should be internal CAD capabilities, and of course record of timely performance. It requires geophysicists, it requires surveyors, it requires CAD engineers. So it's basically a SUE engineer should have knowledge of all these fields. Engineering Council of India and INDSTT, along with the AF Academy as a training partner, have started a system of certification of SUE engineers, where we give them a numbered stamp valid for 5 years of time. They have to go through a particular course, and after that they get this stamp so that they are able to put this stamp on the underground utility maps, and then only that map becomes acceptable. So the Indian standard very clearly defines this also. What is a subsurface utility engineer? The drawing prepared using the process of SUE should finally be stamped and signed by a certified SUE engineer, should be conversant with various tools required, etc., CAD drawing. So this is something which is now in Indian standard. So very soon, most of the departments or organizations are going to make it mandatory that each underground utility drawing should be stamped by a certified subsurface utility engineer. We are in process of creating these engineers. Already India has more than 100 engineers certified. Standardization is in terms of survey grids, level linked to MSL, coordinate system, use of multiple technologies, clear identification of quality levels, experience, manpower, and equipment. Now, once we have gone up to here, this is almost the end of this presentation. Before we open this for our question and answer, I just want to ask you a quick question again. Okay. It's the same question which I asked you. In your opinion, which is the most suitable, appropriate method or procedure to create maps of underground utilities? GPR, EPL, trenching, or SUE? Because this is the crux of the entire webinar. This is where we are looking at what is the right process to make these maps, a particular tool or a process. I'm very happy to see that we have 87% saying SUE, 11% GPR, 0% EPL, and 0% trenching. So wonderful. For these 11% who are saying GPR, please change your thought from GPR to the process of SUE. GPR is just one tool in the entire process of SUE. If you are relying only on GPR for detection of your underground utilities, 40% success, 60% failures. All right. So now if you want to learn more about this, we have entire SUE course which is available. Module 1 is Introduction to SUE, which we have just done with you. Module 2 is quality level D and C. 3 is quality level B, that is GPR data acquisition. Module 4 is quality level B, that is GPR data processing. Module 5 is quality level B with EPL, acoustic, gas tracker, and other methods. And module 6 is quality level A and drawing preparation. So these 6 modules together make the entire course of SUE. Now, again, you have two options if you want to pursue this further. First option is learning with certification. That is, this is a comprehensive course which covers all the aspects of SUE, including GPR, EPL, etc., right from quality level D, C, B, A, with all the methods. Upon successful completion, you will be given an awarded INDSTD Trade Skill Certificate for SUO 1.1. It is approved by Engineering Council of India for award of 24 professional development hours. And this is designed by industry experts, all through videos. There are 5 hours of videos and 700 pages of optional reading material. Detailed training on data processing using live software. For example, GPR data processing, it is all given training by using live software. And you have liberty to complete it in 2 days to 2 years. That's completely up to you. And this is your first step towards certification as SUE engineer. If you do this course, your level 1 is considered to be completed. For level 2 and 3, you have to anyway attend a one-day workshop with some practical experience on the equipment and go through a small live webinar. It's for one day. And after that, you will be given the stamp and certificate as a SUE engineer. We have around 100 certified SUE engineers as of now. The full program fee for this is INR 16,000 or USD 300. Now, for next 2 hours, you have a discount coupon WEB50. You can use this discount coupon in next 2 hours to get 50% discount. So it will be for 8,000 or USD 150. I'm sure Rashik ji already has put option 1 in your offer window. If you go to your offer window, this option will already be there, so you can go for this option. Option 2 is for people who do not really want any certification. They just want to go through the same course for skill enhancement. So exactly the same course, the same videos, the same reading material can be given to you in option number 2. It is for skill enhancement, of course, and the same course, 5 hours of videos, 700 pages of optional reading material. Now this full program fee is INR 8,000. But in next 2 hours, you can register for this with a heavy discount, only first 50 registration for INR 1888. This is inclusive of GST. It's actually 1600 plus GST, so which makes it 1888 or USD 30. So you have, depending on, well, if you are, for example, a young engineer who wants to get certified at SUE engineer, please go for option 1. If you're already a professional, you're working in your field, you're not changing your field, but just want to learn a little more about SUE, please go for option 2. So I'm sure Rashik ji very soon will put this option 2 also in the window. All right. Okay. So with this, we come to the questions now. So now if you earlier asked any question, please. Okay, option 2 has been put in the chat. This is hmz.io. So this is basically the link where you can go and register for option 2. If you register for option 2 today and like later you want to upgrade for option 1, you have to pay an additional fee of INR 8,000. So then that course which is today being offered at 8,000 will become 8,000 plus this particular fee, but only for the people who already have registered for option 2, not for the fresh entrants. Now, can we have the questions, please? Even if you asked the question earlier, please put it here now. Okay. First question, do we use GPS coordinates in SUV? A very interesting question. As I said, that it is desirable to have a standard coordinate system in SUV for the simple reason that if you use a local coordinate system, tomorrow it might be very difficult to know exactly where are you working. That's reason number one. Number two, if you're working in a city, today you have done one street, tomorrow you have done the second street. Now, after working for let's say 4 or 5 years, you want to put the entire data together. It's good to have that in a single coordinate system. So it's good to have a standard coordinate system. Now, when we talk about GPS, DGPS, I'll not get into that because GPS coordinate system are not good enough for SUV work, because here we are looking at accuracy in terms of sub meters or sub centimeters in certain cases. GPS is not good enough for that. So a standard coordinate system is the answer. What if only cable is lay more or 2 meters in one place? Can it distinguish it? What if only cable is lay more? I'm sorry, this question is not clear to me, Mr. Vivek Kumar Sharma. Please repeat your question again. Okay. Can we ascertain the type of soil and depth of it? Type of soil and depth. There are different methods for finding a type of soil. There are different geophysical methods by which you can find different layers of soil. You can find out, whether it is loose sand and after that is a clay layer, etc., etc. So there are different methods for doing that. GPR in general just gives you different stratification. It doesn't tell you the type of soil for the simple reason it is working only in the principle of reflection. What are the laws for storing and sharing the SUV data and work one project's output for another one? There is absolutely no data, central data sharing at this point in terms of SUV. If water table is there, can GPR be used? A very good question by Mr. Murthy. Water table is there. If it is fresh water, it doesn't create much of the problem. GPR can be used. If the water is saline, it increases the conductivity. GPR penetration becomes a problem. And that's why there is no definitive answer to this question. Again, it all depends on the conductivity of the soil and attenuation it is offering to the EM signal. So remember that just because water table is there, do not say GPR cannot be used. It will depend on the mineralogy of the soil, whether it is making it so conductive that GPR signal is not penetrating beyond it. How SUV helps in deep foundation engineering like pile driving? Oh, of course. Once you're driving a pile, Shalini M, once you're driving a pile, you need to be very sure about whether there is existing utility there. So you need to detect your underground utilities, and SUV has to be conducted there before you drive a pile. Is there any BIS code for SUV? I just told you we have developed this code. This code has been developed by Indian Society of Transist Technology, INDSTT, in 2018, and hopefully it will be taken up as a BIS code soon. But as of now, it is INDSTT code. Do we have any tool to measure the pavement layers in non-destructive method? Tool to measure the pavement layers is being done regularly using high frequency GPR. We have been doing it for airports. We have been doing it for roads. It is definitely possible. How can we detect utility deeper than 3 meters? Well, there's no problem. Depends on the soil conductivity. If the soil is good, in Delhi, we have detected utilities up to 7 meters. So again, all this comes to a process of SUE, subsurface utility engineering, starting with quality level D, going to C, going to B, where you have number of tools available. Now, which tool it will be depending on what is the problem at hand, what is the site condition. Why EPL creating unnecessary sound in the rural area? Why EPL creating unnecessary sound in the rural area? I don't get this question. EPL makes the beep sound when it detects a charge carrying conductor, but that's where it makes the sound. I don't know what sound you're talking about, Gaurav. If you can just put it back again in the question. Is Mala GPL reliable to work? We actually can't look at any utilities with that. Can you just give us any setting in our GPR system? Well, Mala is one of the very good GPRs available in the market today. So as I said, it is not about the equipment. It is also about the soil. Same equipment can work wonderful in one particular soil and can be absolutely useless in a different kind of soil. The people who ask me what is the depth of penetration of GPR, entire Antarctica ice thickness of 5,400 meters has been measured using GPR. So there the depth of penetration of GPR was 5.4 kilometers. But if you just take this sentence and tell someone that Dr. Rana told that it's 5.4 kilometers, he'll call me crazy. In normal soils, it doesn't go more than a few meters. In granites and basalts and all, it can go 30, 40, 50 meters. When you're talking about utility mapping, 6, 7 meters. Again, it depends on what is the diameter, depth ratio, etc. So it's slightly advanced. I have 3 sessions on GPR in that course which I just talked about. You really have to work on that. What is a radargram? Radargram is nothing but the output of a GPR. So what you see on the screen where number of traces have been put together in a 2D profile, that's what we call radargram. What is the maximum depth of detection of utility is possible with GPR? Depends on the soil condition. As I said, I have done deep sievers up to 7 meters in Delhi, brick sievers or the British time. Depends on the soil condition. There is no single answer for this. For a composite dam, top of core has been damaged, but extent of damage whether can be ascertained from top of the dam by GPR. Please, the dam safety is very close to me. There are 7 or 8 different techniques which we use for dam safety. Please, I will leave my email ID of this presentation. Please send me the complete information of the dam and the problem, and I would love to respond to you. How water table at shallow depth affects over precise utility detection method? I answered this question already. It depends on the soil mineralogy and the water table. But if you use the process of SUE, you're not depending on one particular method like GPR or EPL and all that. So chances of success are very, very high. Okay. A newly constructed and developed city having knowledge of all underground data with reference to MSL, is it 100% reliable? Well, I don't know. It depends whether they're updating this database. If they created this database, first of all, I don't know, at least because you seem to be from India. At least in India, I don't know any city which has this 100% database of underground utilities. But if they are not updating it, they are not changing it with the changing topo features, it will become redundant. It will become obsolete in no time. Multi-wood power cables emanating from a single source, can we differentiate the cables? Yeah, well, if you're able to put your EPL connector in different cables at different places, you might be doing it. And again, please use the approach of SUE. All right, soil investigation has the right type of soil. Yeah, of course. Does quality level A inclusive of quality level D, C, B, or quality level A is enough? No, Mr. Amit Kumar, please don't take that message home. SUE is a process. It starts from quality level D, it goes up to quality level A. How can you indulge in quality level A unless you have, for example, detected your utility by quality level B? Then you are again going to trenching. We are not talking of quality level A as trenching. We are just making small holes of 20 centimeters by 20 centimeters to verify the exact location and the depth and the type and the size of the utility. That's what quality level A is. Okay. Mr. Saurabh, please write to me separately about tunnel construction. Kindly, I will love to help you with that. We have actually come up with a standard on tunnel construction with the Tunneling Association of India. I can help you with that. Okay. Does utility depth will give accurate by GPR? Depends on how well you're interpreting the data. Still 5 to 7% error is unavoidable. Okay. What's the geophysical method in detection of paleo channels? So, well, you can use electrical resistivity imaging, you can use MASW, you can use GPR, depends on the soil conditions. What sort of extra efforts we must put in processing of data of GPR from a drone as compared to that of ground coupled one, where you have to do a lot of different processes there, because now your antenna is at a distance from the ground. There will be an initial reflection which is coming from the ground surface. You have to shift your time zero. There is certain changes, but most of the software which are available can handle that. Okay, I'm skipping few questions which I already replied in some way or the other. Okay. How effective to measure voids in the field land? filled land. Well, voids can be detected using different methods. There are different methods for that. GPR is one of them. MSW, ERI, microgravity. There are 4-5 different methods. Please, again, if you have any specific query for this, just write to me. I'll send you this. Do we have both codes in Indian condition? You can use just INDSTT code. That's the latest code which we have come up with. Okay. Okay. All right. So I have lots of questions here. Most of the questions are actually focused on a particular equipment. Can GPR do this? Can GPR do that? Can EPL do this? Can EPL do that? As I have been saying, that this entire purpose of this webinar was basically to get away from tool specific approach and take it to a process specific approach. Till the time we start talking of different tools, we are limiting ourselves. If we feel that GPR is something which we will be using for all kind of utility mapping, we are limiting ourselves. Please get out of it. Once you go to the SUV approach, everything is possible. For the simple reason that you're first finding out what is the underground utilities in this particular area, coit level D, then you're going for surface appendices. Then you have 4 or 5 different methods available to you, even in the urban areas. I have already showed 4 methods in my presentation: acoustic locator, gas pipeline tracker, GPR, EPL. They practically solve all the problems related to what you call urban environment. So please go to the approach of SUE rather than tool specific approach. Okay. Is GPR processing done through system or in system and human intervention, not through system only? Mr. Bopanna, quality level D data or quality level C data ideally has to be there if you really want to go beyond just detection. So it has to be there. Can we use GPR for subsoil investigation? It is used for a lot of geological investigation. Okay. All right. Okay. Now I have my email ID. I am writing it here. Okay. I've tried to answer most of your questions, but if I have not been able to, and I've skipped certain questions which were not directly linked to the topic of today, SUE, you have my email ID, that is sanjay@parson.biz. Okay. SANJAY@parson.biz. Please feel free to write to me. And whether it is related to tunnel, dams, cavities, we have case studies and papers available for all of them. Please write to me. In some cases, when we don't have old data, then can we still carry out SUE? Sure, you can carry out SUE. See, it is not, that's what I said, it's a flexible approach. It doesn't say that you cannot work on SUE unless you have this. So unless you have completed quality level D, you cannot go forward. No, whatever is, it's a process. Wherever you can start from, you can start from. That's not an issue. Okay. All right. I'm sending my email ID again. I'm sending on the general chat so everyone can take it from there, please. Okay. And I'll also request Rashik ji, the moderator, to actually share my email ID with all of you, so that you can send me your questions later also. All right. So I hope all of you have got links to both the offers which were given to you. Say yes if all of you have got all the offers, both the offers, offer option 1 and option 2, all of you have got that. Just do a quick yes. Great. So you have got the offer, both the offers, and of course you're free to choose any of these offers in next 2 hours. We'll keep the window open for next 2 hours, and after that it will expire. And in between, if any one of you need any further assistance on this, may I request Rashik ji to please come and share his contact details, so that if anyone wants to interact with him regarding these offers, he can directly maybe message you or talk to you. Okay, anyway, it's available here. I'll just copy and paste it again in your message box. So okay, here are both the offers. Option 1, use discount code on this. Option 2, use discount code on this. Okay, and this is email ID of Mr. Rashik, which has come, and you can please write to him if you have any question about any offer. Okay, so this is his email ID. Please feel free to interact with him for both the options which are there. Okay, all right. All right, friends. So I think it was great to have you, and we have finished almost on time. It's 6:06. We are 6 minutes late. I think we can give this 6 minutes late to slight interruption which we had in between. Otherwise, we have been very punctual. So thank you very much once again. And if you really like this session, please give your comments. And I really urge you to go to one of these options which have been presented to you. Option 2 is almost free. It's 1600 plus GST, so it's 1888. You can go for that option, and then of course later on if you want certification also. But this will be a great option for your knowledge enhancement. So thank you very much, and see you in the next webinar sometime soon. Thank you. हाँ जी सर छोड़ दो रूम पे